Hello everyone. So here we are going to discuss about the topic on soil factors affecting greenhouse gas emission. Okay. So this topic usually we don't get much content. Okay. And this topic is very important because it is also related to the ecology part of the paper one. Okay. And this comes under the soil science part, but it is also useful for paper one of ecology part. Okay. That I'm just saying. Okay. So first you should remember like what is the contribution in agriculture? Around 28-30% is the contribution of greenhouse gas emission from agriculture. Okay, mainly in India. And if you take soil factors, uh, like if you take the major ones, so it will be like rice cultivation. Okay, some 23-25% greenhouse gas emission is there. Then the number one is the organisms, the rudimentary animals, which are contributing, okay, up to 55-60%. Okay, but rice cultivation alone contributes 23-25%. Okay, so this basic you should remember. So here the topic is on greenhouse effect and greenhouse gases. Okay, what are the important ones? Okay, the major greenhouse gases are CO2, okay, methane, nitrate, like chlorofluorocarbon, all these things. Okay. Among these, for agriculture, the most important is CO2, okay, methane, N2O, NO, N2 are the main greenhouse gases for agriculture, and it is from the agricultural soil. Okay, because the syllabus topic is on agriculture soil. So the major reasons, if you look, okay, and the reasons are because we are going for tillage. Okay, because when you till the soil, there is release of CO2. Okay, that's why we talk about conservation agriculture, why it is beneficial, how it is having environmental benefits. So all these things are correlated with that. Okay, so tillage is one reason. The fertilizer application, directly if you're applying the phosphatic and then nitrate fertilizers, then slowly it can be emitted into the environment. So all those factors are also there. Then irrigation. Okay, so this we will discuss in detail how irrigation can lead to different greenhouse gases. And as I told you about rice cultivation. Okay, because rice cultivation is like in the case of puddled rice. Okay, puddled rice. So that contributes to methane emission. Okay, because there is standing water, there is anaerobic condition that is prevalent in the reduced zone. Okay, so the major soil factors are one is the microbial activity. So what do you mean by microbial activity? Like what happens is that the microorganisms use CO2, N2O, and CH4 for microbial survival. In the soil, they want to survive. That's why they use these the nutrient components. And the production of these greenhouse gases depend on the factors like the redox potential, soil organic carbon, and electron acceptor, and other factors. Okay. So majorly in case of microbial activity, we use CO2. Okay. What happens in CO2? The microorganisms break down the carbon bonds of organic compounds and provide energy for their survival. Okay. The microorganisms break down the uh, carbon bonds of organic compounds. Okay, because the organic compounds, whichever, like even if you use the FIM in the soil, so that will be broken down and the production of CO2 happens by the microorganisms. Okay, so the next component is the N2O release. So how does N2O release happen? It happens in the anaerobic condition. Like anaerobic means, like as I told you about the puddled paddy. Okay, puddled paddy means when the standing water is there. Okay, that we usually call puddled paddy. Okay, so what happens is here it hinders decomposers. Okay, decomposers will be hindered because decomposers will be active when we have aerobic factors. Okay, more. But anaerobes usually survive by using nitrate, okay, Mn4 plus, Fe3 plus, and H plus. So these usually are utilized by anaerobes, okay, microorganisms. So this will be like act as an electron acceptors. Okay, and another class is denitrifiers, denitrifying bacteria, okay, or microorganisms. So they use NO3 as electron acceptor. Okay, so these factors will happen in the what do you say, puddled rice. Okay, so just remember the classification, not like in may not be in much detail how the chemical reactions go, but at least you should know the heading. Okay, maybe it may be asked maximum in 10 marker. Next is CH4. Okay, so how here happens is because prolonged anaerobic condition. Okay, in soil causes major oxidants like O2, NO3, Mn4 plus, Fe3 plus, and SO4 2 minus, like this. Okay, similarly in this, as you see, so in case of anaerobic condition, this components will be exposed. So this also majorly in case of rice fields. Okay, and next another factor is soil humidity. What do you mean by this soil humidity? Okay, so it says that the greenhouse gas emission is like directly proportional, okay, to the microbial activity is with respect to soil humidity. Okay, means if soil humidity is increasing, okay, so the green is so there will be increase in like microbial activity also. Okay, soil humidity and then microbes. So there will be uh, correlation between the soil humidity. And when soil humidity increases, there will be microbial activity also increases. And this in turn leads to greenhouse gas emission. Okay. So if you want to understand in detail, so it states that soils with less water-filled pore space show higher emission of nitrification, CH4N2O producing bacteria, require like anaerobic condition like wetland, paddock, cultivated land, and correlate positively with soil humidity. Okay, so all these things are positively correlated with soil humidity. Next is soil pores size and texture. Okay, so here we see that if we have a dominant fine pores, okay, it supports the formation of CH4 and N2, okay, under anaerobic condition. But CO2 emissions are in fine textured soil, okay, compared to sandy soil. If you compare the fine textured and sandy soil, CO2 emission will be more in fine textured soil. Okay, so the next is like soil water content and oxygen concentration. So here it states about soil water content and oxygen concentration. Okay, so the CO2 emission from soil is linearly increased with the soil water potential until saturation. Okay, so here we have CO2, okay, with this, and here we have soil water potential. So it increases with the soil water potential and it reaches an optimum and then tapers. Okay, till saturation it increases linearly, then from there it tapers. Okay, so the production of CH4 requires very low redox conditions. Okay, as in prolonged waterlogging like in paddy, as we discussed. Okay, then the other important is soil pH. Okay, it also has a very important effect on microbial population. So what happens here with CO2 production, which in turn affects the greenhouse gas emission from the soil. Okay, so here what we need to understand is that the CH4 production is maximum at neutral pH. Like if you take the graph, okay, so CH4 production is maximum at pH around 6, 7. Okay, because this is the pH in which the methanogens, which are the bacteria, which will act. Okay. Next is the nitrification increase with higher pH value. Means nitrification has to happen. It happens usually at pH around 8, 9, and nitrification process. Okay. So, and increases with higher pH values. And another important factor which you should remember is denitrification process. Okay, this usually happens. Okay, in case of alkaline pH. Okay, as you see here, no emissions are caused by denitrification. Under acidic, no emissions. Okay, so as I said you, in alkaline pH only this denitrification process will occur, not in case of acidic soil. Okay, in acidic soil, denitrification process will not occur. Only in case of alkaline soil, denitrification process will occur. Okay, the next important which we studied, so methane. Okay, the CH4 emission usually happens in pH around 6 to 7, nearby the neutral pH, because the methanogens are always active. The other important is The other important which we said is like nitrification increases with increasing with higher pH value. So these are the different factors in which how the soil conditions play a key role in the microbial activity. Okay, this pH. Okay, how the microorganisms act, and in turn how the particular nutrients act. Okay, some things I'm intentionally not like going into deep because whatever I notes I prepare, these are from some higher quality books. So there are some higher information which may not be like this much may not be required. So whatever we can, so giving more content so that whichever 2 3 points you can take and that would be sufficient for you in the exam. Okay. So the soil temperature also plays very key role. There is no question. Like soil organic matter decomposition increases with microbial metabolism, which turn increases the CO2 emission. Okay. So the basically we believe that 30 to 40 degrees Celsius for methanogenesis or the methanogenic bacteria, like I told about CH4 production, for that it is required. Around 25 to 35% for nitrification bacteria. Okay, so it shows that temperature also plays a key role. Yeah. So these are the different factors, the major factors which we discussed. So the next is like uh, I told you in the uh, starting the phase only how the different factors affect. So just a brief that if you go for tillage, so there will be increase in CO2 emission. Okay, that's why we are going for conservation agriculture practices. You can correlate them with these practices. Here we don't, we go for zero tillage. Okay, so this is also resource use efficient technique also. Okay, so tillage is there. So next is rice cultivation. Okay, so I told you how rice cultivation, methane emission. Okay, in puddled rice, and around 23 to 25% we have methane emission from the rice fields. Okay, that's why we can also say to some extent we can reduce them in system of rice intensification. Okay, and other practices. Next is additional, like if you use fertilizers and organic matter, that also will lead to more amount of greenhouse gas emission. Okay, so these are the important factors which we need to remember. Okay, because it is a rapid revision course, some aspects I am just telling and going ahead because if we start taking in detail, it will be like 1 hour or 2 hours. So, but these are all key points which I've discussed. If you remember these points only, then you will be definitely able to answer to this topic. Okay, which has less content.